This is page 8 of the exponential and logarithmic function review for Math 30-2. Let's continue solving equations. So last lesson, or last video, stated there are two main ways to solve an equation. So when x is the base, we are going to isolate x, then cancel out the exponent using the reciprocal power. And then the second way is if x is the exponent. If x is the exponent, first we want to isolate the power, and then you have two options. Write it as a common base if possible, and if a common base is not possible, convert to logarithmic form. So for this one, we have to do that first step of isolate the base first. That means we need to get 3 to the power of x by itself by dividing both sides by 2. So when I divide both sides by 2, the 2's on the left-hand side cancel each other out, and we're left with 3 to the power of x. And then on the right-hand side, I have 162 divided by 2. So that is 81. At this point, I actually have two different ways to solve this. I can convert it to logarithmic form. There's no harm in doing that, or I could do it as a base of 3. So 3 to the power of 4 is 81. So 3 to the power of x equals 3 to the power of 4. At that point, since my bases are the same, I can equate the exponents, and I have my final answer. Okay, the second one, check to make sure that you have the base by itself, which I do. In this example, I cannot find a common base with 20 and 3, so that means I'm going to go ahead and convert it to logarithmic form. So log base 3 of 20 equals 2x plus 5. So now I want to figure out what log base 3 of 20 is on my calculator. I'm going to show you two different ways to get that depending on whether you have an old calculator or a new calculator. So on the old calculators, the TI-83s, you're going to type in log 20 divided by log 2. So the log of the argument divided by the log of the base. Oops, I have the wrong number there. That should have been a 3. Okay, so that's what you're going to do if you have a TI-83. If you have a new calculator, you're going to press math. You're going to go to log base, and then you're going to push in 3 and 20. And both of those are going to give me the same decimal equivalent of 2.72683. So remember not to round until the very end. So I have 2.72683 equals 2x plus 5. So now I want to solve the equation for x. I'll subtract 5 from both sides to get negative 2.27316 equals 2x. And then my last step is divide both sides by 2. Okay, I get my final answer of x equals negative 1.14, rounding to the nearest hundredth. And then just a reminder how to solve it graphically again. So you're going to put the left-hand side in for y1, the right-hand side in for y2. Okay, I know I'm going to have to adjust my y max to be 20 because I have a y2 as 20. I'm going to press graph, see what I see. Okay, looks like I can find that intersection. Second, trace 5 for intersection, and then enter, enter, enter. And it tells me negative 1.13658. So that's great, we did it correctly. All right, let's try example number 6. If log base 2 of x equals 6, and log base k of x equals 3 over 2, find the value of k. The first thing that I notice is I don't have enough information in that second logarithm to find k. I need to have all the other pieces in order to find k. So that means I'm going to start with the first logarithm. So to find out what x is, I'm going to convert it to exponential form. So the log kicks the 2 over to the other side, which bumps up to 6. The x stays while the log runs away. So now I know x is actually 2 to the power of 6. And 2 to the power of 6, that's 64. Now that I know x is 64, I can take that and I can put it into my second equation for my argument. Okay, remember that if you have a logarithm, the best way to solve that is to convert it to an exponential. So I'm going to convert it to an exponential. I get k to the power of 3 over 2. 64 stays while the log runs away. And then to solve this exponential, when the x is the base, you're going to raise it to the power of the reciprocal. Remember that if this is not a written response question, you are free to do it through guessing and checking. You are free to do it graphically. You can do it however your heart desires. Okay, so I'm going to type that in. For the older calculators, use brackets around your exponents, and I get k equals 16. Beautiful. All right, let's review the laws of logarithms. So all of these log laws are on your formula sheet. So make sure you familiarize yourself with them. When you are doing log laws, you're going to want to make sure if you're trying to simplify to a single log, you want to do the last one first. So this is the log law that says the number in front of the logarithm here, n, can also come in as an exponent on your logarithm. So that's the one you want to do first. And then the other ones, if you have the same base, you're adding the logarithms, you can simplify it to a single logarithm by multiplying them. And if you are subtracting logarithms with the same base, you can simplify it to a single logarithm by dividing the arguments. Okay, so let's give it a try. So for the first one, it says simplify to a single log. So I notice right away I see this 2 hanging out front. So I know that has to be dealt with first. I am going to bring that in as an exponent on my 3. Everything else is going to stay the same. Okay, 3 to the power of 2, I'm going to evaluate that, and that is 9. Okay, so now I have log base 6 of 9 plus log base 6 of 12. So because I am adding these logarithms and I'm trying to get it to a single logarithm, I am going to multiply 9 times 6. That's the first log law written above, and 9 times 6 is 54. Okay, and that is my final answer. We're trying to get it to a single logarithm. It did not ask us to evaluate. Okay, the next log, simplifying it to a single base. I see that we are subtracting 2 logs, so I look up above, and the one that is subtracting 2 logs brings it to m divided by n, 32 divided by 7. Was my argument. 32 divided by 7, I don't think that gives us a very nice decimal, so we can just leave that as a fraction. All right, let's go to the next page. I accidentally have a repeat question here, so you can skip that. And let's try with some variables. So I notice that none of them have a number in front of the logarithm, but I do see that I am adding the logarithms. So if I'm adding the logarithms, that means I am going to multiply the arguments when I bring them to a single base. Now, for a question like this, you also need to know your exponent laws. That's supposed to be a Z. Which says y to the power of half those exponents we were multiplying. Y to the power of 4 and z to the power of 3. So that's going to be my final answer. All right, the next thing that we looked at when we talked about exponentials and logs was solving problems. So this is kind of tied into both of the units because a lot of the times you solve exponentials by converting it to a logarithm. So I have written here, when creating an equation, start with y equals a times b to the power of t over p. So remember the key features about this. A is the initial amount. So say you're starting with 100 grams of gold, or say you're starting with $3,000, whatever your starting amount is. And just a reminder, that is also going to be your y-intercept. Okay, next we have y. Y is the final amount. So say your gold decreased to 50 grams. That's going to go in for y. Say your money increased to $5,000. That will be your final amount. Okay, the next one is b. B is your growth rate. So this one has a lot of different options for what it can be. So I have broken it into 4 different sections. If you have a doubling time question where it says, oh, it doubles in this amount of time, then your b value is going to be at 2. If you're talking about a half-life question, your b value is going to be 1 over 2 or 0.5. And then we have either percent increase questions or percent decrease questions. So for a percent increase question, you are going to convert your percentage to a decimal first, and then you're going to add 1 to that decimal. So 1 plus your rate of increase as a decimal for your b value for increasing questions. And then the last one here, 1 minus your decrease as a decimal for decreasing questions. So knowing those 4 different things are very important and will help you a lot when you are creating the equations. Okay, T is our time, and then P is the length of one cycle. So for example, if it says the doubling time is 5 hours, then P is going to be 5. So it's the length of one cycle. A lot of the times for our percent increase or decrease questions, the cycle will just be 1 for 1 year. All right, let's give it a try. Example number 8 says the population is given by y equals 1,500 times 1.03 to the power of x, where y is the population size and x is the number of years. Okay, so the first question is what does the 1,500 represent? So the 1,500, if you look above, that is our A value. So that is the initial population. We don't even know what we're talking about here. It might be aliens for all we know. So initial population is 1,500 things. We'll go with things. Okay, next is the rate of growth. So the rate of growth comes from that b value, 1.03. So in order to find our rate of growth, our formula for that is b minus 1. So 1.03 minus 1, and that gives us 0.03. So that is equivalent to 3%. So there is a 3% increase per year. If you were to get minus 3%, then that would mean that the exponential function is a decreasing function. And that lines up with our b value that we talked about in the first lesson, where if b is greater than 1, it's an increasing function, and if b is less than 1, it is a decreasing function. Okay, next we have predict the population in 10 years. So 10 years is our t value, or our x value in this case. So y equals 1500 times 1.03 to the power of 10. So for a question like this, if you are given the equation, you are welcome to use it however you see fit. And if that means typing it in like this, feel free to give us our population of 2016. The other way that we were to do this in the past would be to graph it. So you would graph 1500 times 1.03 to the power of x. And then you would go second function trace, and you would type in 10 for the value, and you would get the same answer of 2016. Okay, for the last one here, what is the population at 10,000? So now that 10,000 is a y value. So most commonly, the way that you have done this in the past is to put in 10,000 in, oops, I didn't mean to delete that, 10,000 in your y editor, and then you could also put in the original equation, which I just deleted. And then you are going to have to play with those window settings. So remember to put your y max to the y value that you typed in, which was 10,000. Okay, I'm also going to extend my x max to, let's just say, 1,000 for now. Oh, perfect. I can see my intersection. So now I'm going to do second trace 5, enter, 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 and I get my answer of x equals 64. Remember, we can also solve this algebraically, and I will focus in on that in the next couple questions. So the units for this is, when is the population at 10,000? That would be 64.18 years. Example 9 says caffeine has a half-life of 8 hours. How long does it take for 370 milligrams to decay to 80 milligrams? So if I think about my equation, y equals a times b to the power of t over p, I can start plugging things in. I also know my starting value is 370. I know my final value is 80. I know my b value is 0.5 since it is a half-life question. And I know that I'm looking for time and my period is 8 hours. So this one I will solve algebraically. So isolate our power first. Divide both sides by 370. Okay, so I'll just leave that as 8 over 37 for now. After I have isolated my power, now I can convert it to a logarithm. So log base 0.5, and then my argument is 8 over 37 equals t over 8. So let's go ahead and find what the left-hand side of the equation is equal to. Okay, so 2.2094 equals t over 8. And then we have to multiply both sides by 8 to get t by itself. Okay, so I get 17.7 hours for the time. So always ask yourself, does that seem reasonable? If it's going down by half every 8 hours, yeah, it seems reasonable to me. We definitely shouldn't be looking for a negative number or a number bigger than 270, so this looks good.